Good morning, good afternoon, and welcome to our webinar today. Whether you're live or you're watching a replay, we are very happy to have you here today to listen to our webinar on Automotive DevOps, Automating Quality, Safety, and Security. My name is Matt Klassen, and I run marketing at Parasoft, and I have with me the esteemed Arthur Hicken. I'll introduce him in a little bit more detail in a minute. But before I do, a couple of things. Number one, of course, the replay, many of you might be watching replay, but replay is obviously going to be available kind of automatically. Upon request, we can provide PDF of slides. In this case, this is mostly discussion, so I don't know that it'll be that relevant today. But if there's anybody that wants to request that, that's of course something you can do. And then Q&A, use the Q&A facility, right? Type in your questions, the Q&A within BrightTalk, and we will be answering your questions at the end. We're hoping to keep this discussion to about 30-ish minutes and then go to some questions. And so, likely 45 minutes tops is the goal here. So with that, let's talk a little bit about what we're going to talk about. So I'm going to do a very quick introduction, just a moment, and then to the topic, and then we're going to jump right into discussion with Arthur, and we're going to talk about how software effectively isn't just eating the world, it's defining our vehicles as we know them. And then where does that put development and engineering groups with software, kind of busting at the seams within the modern vehicle? Where are they on their road to DevOps or automotive organizations, engineering organizations, whether you're an OEM, tier 1, tier 2, supplier. But then there's, of course, some complexity that comes in with compliance, safety, security, requirements, standards. We'll talk a little bit about that. How does that affect your sort of path to automating your CI/CD and DevOps pipeline? And then finally, again, kind of the automation, right? So how do you continue to become more efficient through automating your tool chain, and what does that sort of look like? And I will share a slide that kind of depicts what some of the leading organizations that we work with are doing, what that looks like. Then we'll go to Q&A, and then we'll also talk a little about some next steps for those of you that are interested in more detail. So this is kind of a high-level introduction to this concept, sharing some examples from industry, and having this discussion with Arthur. So with that, I'll just introduce Arthur Hicken. So he's also known as the Code Curmudgeon, and he's an evangelist. He's been here for many years at Parasoft, and he's been working in this realm for many years, and has a ton of experience within cybersecurity, functional safety, right? DevSecOps, the SDLC, etc. He runs a separate website, IoT Hall of Shame, for those that are interested, and can be reached on Twitter and other ways as well. But there's his handle as well. So with that, hey, welcome, Arthur. Thanks for.
Hey, Matt. Good to be here. Cars are always interesting, right? I mean, it's just like we all like cars. I think everybody's interested in cars, and so it's always a fun and fascinating area. And right now, it's such an area of change and innovation that I don't know that we've ever really seen an era like this in our lifetimes. Right? We're too young to have gone through the earlier waves. So, yeah, I think it'll be fun.
Yeah, I think it's well, I think so. You liken it to, I think this is even more profound. I'm helping my son restore a 1973 VW Type 3. It was one of the first vehicles that had fuel injection. In fact, I wasn't aware of it when we bought it, brought it home. He's ripping it apart, and I'm like, what's this box? It looks kind of like something, electronic, and where's the carburetor on this thing? And it was so, researching, we're like, oh, this is like one of the first vehicles ever to have electronic fuel injection. which to me, I'm like, let's convert this thing. And he was, committed to trying to keep it. But anyway, there was obviously that led to a whole set of change in automotive in the 1970s, when you went from like classic vehicles with, chrome bumpers to all sorts of safety features as well as electronics on the vehicles. And it also went from an era where people could kind of felt like they felt comfortable working on a mechanical machine to feeling less comfortable as electronics and electric, components, if you will, kind of started dominating the landscape. But I think this revolution is even more profound with electric vehicles and autonomous vehicles. Specifically, obviously, from what's near and dear to our heart, which is software. So I don't talk a little bit about that, how we've come to this whole notion of a software-defined vehicle.
People have been tossing this term around now for a couple of years with software-defined vehicles, and I have to say that being a curmudgeon, my initial response was whatever, right? Like it's a marketing meme, it's a message. But I had this experience with a car 3 years ago that I bought, and I'm not going to mention brands here, right? I don't want to like irritate anybody because cars are cars. Okay, so I bought this car. It was a newer car. It had the most features of any car I had bought. It had ADAS systems, lane keeping, fancy cruise control, the good, fast follow cruise control, which in LA is just so important, right? Cruise control is useless without these new features. And being a software guy, as I drive the car, I quickly start to understand where the car's deficient, like why it does things wrong, when it does things wrong. And I think, man, if I could just get on the phone and get the right guy on the other end of the phone, I could fix this. And then I also, you hear about, some of the manufacturers doing massive road testing, gathering data, doing machine learning to build better systems. And so my unexpected expectation was, are they going to give me an update? Like I've never had a car before and thought, okay, like, mid-cycle, someone's going to give me a new feature in my car. It's just not something we think about. And yet, with these stupid phones, like we expect updates constantly, whether or not we're updating the hardware, right? We start to buy the phone. There's a few features in a hardware perspective, but fundamentally we buy it because of the things we want it to do. And the expectation for cars there has become that when we say software defined, we say that the features that the software provides, from ADAS to climate control to monitoring to self-parking to whatever, are all more important. The hardware is becoming a commodity item. It's just everybody can build a good car, everybody can make good seats, etc. But that software functionality and especially, like OTA, right? Like without OTA, software-defined vehicle doesn't really exist. But you said one other really interesting thing there, Matt, right? Like you talked about that complexity of how cars used to be really easy to work on, right? Like I have a 63 in the driveway and there's nothing there in the way of plumbing or wiring, right? But we've gone to an era where there's more and more plumbing and wiring, but the software-defined vehicle matches up with the electric vehicle market, and it turns out that they're actually, more simple, right? Like I don't want to misstate how hard it is to develop the vehicle, but to build them, like they're simple systems. They're simpler. You don't have all the plumbing, right? And the wiring systems have become very modern, right? I mean, we're talking Cat 5, right? Like we're moving to CAN bus over Ethernet. So it's funny because we may come back to the age where we can work on the hardware, but I don't know that we, as end users, we'll be able to even touch the software, right?
Yeah.
It's fascinating.
Yeah. Well, I think, and we've seen it with the advent of sensors as an example, right? It's like, hey, they're just replacing, basically widgets, one widget with another widget. And those widgets, by the way, are being reused across brands, which is also sort of new, right? Where creating a new vehicle isn't like, hey, there's some special sauce in the engineering of each component that's really specific to one OEM, right? It's like, no, it's these components are fairly standardized. It's not always true across the board, but fairly standardized and common Even complete, safety critical systems are being purchased from tier 1, tier 2 suppliers, which is good, good news, bad news, right? But it's this black box, which is a little bit, I think, scary for people. And I think that's one of the, obviously relevant to this topic, which is, okay, so the component can just be swapped in and out, a sensor or whatever, but below the surface, right, are thousands, if not tens of thousands, or maybe even millions of lines of code of where one car may implement features that another model doesn't implement, and those are completely software defined, right? Which is part of that definition. Which, how does that? So here's one interesting thing for me is, how does that affect recalls, right? So I think you track this, I think, Arthur, right?
Yeah.
So what does that mean for recalls as we move into this world?
It's fascinating because when you look at recalls over the last 100 years, right? And you see sort of a steady climb, right? Because as complexity increases, the number of problems in the vehicles increases. The number of vehicles affected by recall kind of goes up, and you see spikes occasionally from major incidents like a tire manufacturer, which was probably the first thing to get really reused across brands. But then you see this real spike, starting 10 years ago, where the number of vehicles affected shoots up by like a factor of 10. The number of recalls shoots up by, like 10% a year or whatever, right? But the number of vehicles affected shot up by a factor of 10, and it was because of reuse, right? So yeah, when you start taking apart and use it through the system and then put it on another car, another car, another car, another manufacturer, another car, then yeah, you get it everywhere. So we've moved into, again, a kind of a double-edged sword era with the software, because we are going to have software components, especially from the supply chain, right? Not from the tier 1, not from the assembler, from the manufacturer, but from a braking system or a transmission system or a camera system. The ones that we see the most today is the camera system software recalls. So we're going to see them, but also many of them will be something that can be fixed either really quickly to the dealer, right? I mean, they plug something in a USB and they update, right? But the most modern cars, that'll even be OTA, right? We see Tesla, for example, applying OTA patches. And again, as scary as that sounds, right? Also, we're very, very used to this on our phone. I don't take my phone into the store to have a software update applied. It's unthinkable to me. And if they required that, I would buy a different brand. So I think, recalls are going to go up, but the cost of a recall may go down.
Yeah, that's true, right? I mean, well, it should, right? I mean, there should be something to that. And I think again, Tesla maybe being on the forefront. There are a few other manufacturers that have gone down that route, but when you all you have to do is step into a Tesla and you're like, there's a screen. I mean, like, there's a steering wheel. Okay, there's still a pedal and brake and so forth, but there's like pretty much, there's a screen, and there's not a whole lot else going on there. And you get the sense immediately, like, okay, everything is being controlled through software, and because this is connected, and my phone is now connected to my vehicle, and there's some, I actually do think the analogy you're using with a mobile device, right, smartphone, is actually a really good analogy, because I think it's becoming one, right? I mean, your smartphone and how you control and what you do, and you can call your own vehicle to you with your no hi-ho silver. That was the closest thing maybe to it, where you could call your horse to come up. But now we got vehicles that just roll on up. So let's talk about the DevOps piece here. So DevOps is relatively new-ish term. Again, last decade certainly, where you've actually seen it be used, mainstream. It's kind of a follow-on to the notion of Agile and what Agile did. I think, again, I would say, 2000. I remember working for a software company in 2008, and we went all in on Scrum, and we were, even though we were a pure software company at the time, we were actually doing CI/CD at the time, which was very new for the most part at that point. to actually have an automated tool chain, and it was very kludgy. But now, right? Anybody who does web or cloud development or mobile app development, for the most part, on the large scale, right? This is fairly mainstream stuff. But 5 years ago, even I had conversations with automotive companies and other manufacturing companies, which were like, well, we're never going to, or we don't see putting our entire, pipeline into the cloud, right? And now, right, a Git-based CI/CD pipeline, driving DevOps practices in the cloud is fairly common or becoming more common. So let's talk a little bit about that. Like, where do you see sort of automotive organizations in their sort of evolution towards modern pipelines and tool chains?
It's interesting, right? Because agile has moved from a wonky movement that was in the corner of the software industry, right? Like the kind of a hipster movement that grew because it was effective, right? Like it spread because it was cool, right? But it stayed because it was producing results. And then what we've been seeing is that agile methodology, the thought process, the culture behind it, the ideas are spreading to regular business, right? Agile is no longer a software term. And I always struggle with like the relationship of agile and DevOps. I could easily make the argument that they're the same thing, right? They're not. I could argue that they're two sides of the coin. I feel like they're not that opposite. I sometimes feel, and I might change my mind tomorrow, right? I'm gonna step back and disavow this tomorrow. But I feel like maybe agile is the what and DevOps is the how.
Yeah, I can
Right.
see that. I can see that.
So, and in automotive and other embedded type systems, I think it's really important to say that because you end up frequently with something that's very agile at the moment of coding, and that the agility breaks down as you move toward deployment, right? And you're trying to get away from that. And ideally, you're trying to pull some feedback from the deployment, whether it's, install firmware in a vehicle and ship it, or whether it's, update a server on the cloud and clone it and put it into AWS and spin up as many instances. But you're trying to learn from what's not working and adapt to it. This is the beauty again of the OTA, right? Before, if cars were going out crappy, you had to decide, okay, do we swap parts midstream in the life cycle of this thing? And what do we do about the old customers? What triggers a recall, right? Like, do we do sort of a voluntary thing if they come in, or we do have an involuntary thing? So I think that DevOps brings that ability to do practical agile across the life cycle. And again, software used to be a pretty weird thing in cars. And when I say used to be, I mean like 10, 15 years ago. It was tiny amounts of code. There was a lot of code in a car, but any individual component might have 200 or 300 lines of code. Like an emissions system was 200 or 300 lines of code. And
Yep.
anybody can write that. And I mean, you have to know what you're doing, but like you can look at it, you can manage it, you can test it, you can understand it, you can really be sure that it's doing what it's supposed to do. Now with a vehicle that has all these crazy features, and it's not just, ADAS and navigation and parking and lane keeping, and is there a car next to me and a car in front of me, and should I turn the wipers on, and should I turn the headlights on? Like, you start adding all that up pretty quick. Yeah, you're into, 50 million, 100 million lines of code and growing. And so the DevOps movement suddenly, having a really good build, deploy, test, maybe in the opposite order, build, test, deploy process. Let's hope it's not build, deploy, test in the car. But having that working well suddenly matters. It has to be as good as the hardware. It has to be that it's a good little pipeline that'll produce, not just produce stuff on a regular, reliable, predictable state, but good stuff that'll delight the customer
Yep.
and keep them safe, and not put the company's name in the news in a negative way, right?
Yep.
Because
Yep.
if I get a recall for half my cars, my name is in the news, right? If everybody loves the cool touchscreen that I put on my thing, maybe not, right?
Yeah.
So
Yep.
yeah, and what we've seen is that automotive manufacturers are moving to a very, very modern infrastructure for development and deployment. And at an architectural level, if I was drawing a diagram like what you have that we'll look at later, you can't tell a bank or a social media company or telecom from an automotive company. The basic structure of building software is very, very similar. So the DevOps pipeline lets you move really, really fast. And in fact, I think, again, we're at an inflection point where DevOps, even a couple years ago, was a real game changer for you against your competition. It's moving toward table stakes. If
Yeah.
you're not doing it and your competition is, they're going to move faster than you, period.
Yep. Well, which I think is important. I think if you think about, again, that massive transformation that's happened really within automotive, right? And just the number of lines of code, I think, and actually where you're hiring your talent from. I think this is another interesting thing, right? So it used to be that, you know, the design, the system design, the mechanical design, you know, this is where, you know, these components that were kind of your special sauce as an automotive company, right? Especially an OEM, maybe to some degree, right? Tier 1 suppliers or whatever. This was your differentiation in the market. And although there still is some of that, obviously from a styling perspective and overall objective, you know, in terms of what you're trying to achieve with that vehicle, right? More and more OEMs are pulling software back in-house, right? Again, it could be done anywhere in the world. They may have employees anywhere and everywhere where you would have, you know, intelligent, talented, you know, software engineers. But at the end of the day, they're no longer outsourcing that as often because that is becoming a big part of their differentiation, right? So with that also comes hiring developers that aren't necessarily used to, right, some of the complexities that do come along with developing software in an automobile, which would be similar to, you know, an aircraft or a medical device, which is certain safety security standards, right, that kind of compliance that comes along. So let's talk about how it differs. So again, maybe you know, again, there's a lot of commonality now between automotive development, software development, and other types of software development, but there's also some differences that are really important. So let's talk a little bit about that. How does that add complexity, some of those standards and the compliance around safety and security?
It's interesting because yes, when you're building things for functional safety, right? Like if you're building things where improper usage or failure will, you know, harm or kill somebody, then you have to build to a certain rigor. And again, the companies that build planes, trains, and automobiles are used to this on the hardware side, and they understand how to apply engineering techniques. And it's funny because developers who've come from kind of a free Wild West kind of development where you just code it and if it works, life is good, they kind of struggle and chafe a little bit at these things we call coding standards. And, you know, when I talk to an engineer, standards is a word that has a meaning, and it means that it's the embodiment of best practices that will ensure the highest quality and minimize risk. And when I talk to a software developer who's never worked in that world, they think of standards as someone telling me what to do, right? And it's just not what standards do for you, right? They're actually kind of liberating because they're helping define the world in which you have to live. And so now you don't have to make certain types of decisions. You know that you need to make this safe and that safe, right? We have these different safety levels in automotive, and we know that we have to have certain types of functionality. And even down to you're mentioning like the supply chain with DevOps, right? Like, how do I control my software supply chain? With hardware, again, there's really good known techniques for testing that, you know, the metal has the right strength and the right coatings and the right functionality. How do I do it with software? And the answer is there's certain kinds of testing and processes that work well. And so, you know, the safety standards tend to define higher level processes, right? You need to think about safety integrity levels and define them for different parts and in the context of the vehicle, and think about, failure modes and what to do about it. And then they say things like, well, your software needs to be built well. And they start to define, okay, that means that you do requirements, that you do peer review, that you do static code analysis, that you do unit testing, et cetera. And static code analysis plays a really special role because it becomes a very practical way to translate a coding, a coding guideline or a regulation into something practical that you follow. And it's funny because, again, if we think about the role of the coding standard, Sturstrup helped develop the Joint Strike Fighter standard that was kind of built on top of MISRA, kind of a child or stepchild of MISRA, if you will. And, he said that the point of the standard was to use a subset of the language that was more safe and reliable. And so that's the kind of thing that you have to keep in mind when safety is involved. It's not, will this work? It's, will this work and what will happen, if the car gets hit, if the power gets pulled, if the brake line fails, what can we do about it? So we have master cylinders now, right? So that kind of thinking has to permeate the software industry. And the goal is for standards like 26262 to help us get there. And for, specifically coding standards, AUTOSAR, MISRA, CERT, et cetera, to help us do the right thing without having to sit down and translate the standard from the beginning every time. And even now, dreaded cybersecurity issues, right? Cars are very talkative now, right? They have Bluetooth, they have Wi-Fi, they have weird little proprietary protocols, the keyless entry, the tire pressure sensors, the GPS, the help system, right? It used to just be OnStar. Now my car has a button that says SOS on it, right? Like I can press it, something happens, right? They're very talkative, and cybersecurity is now an issue. And so we have cybersecurity guidelines to think about security, not just the security of the system, but security in a safety context.
Yep. Yeah, I think so that's okay. So you bring up a couple interesting points that I think we should talk about briefly. So one, we've been talking about, as just, full disclosure again, Parasoft is, I think it says, right, automated software testing, although it's got cut off on my little thing, but that's what we do. Okay. And we say automated software testing. It's not, you could define quality really broadly, but a lot of what we do is around compliance. It is around code quality, static analysis, rules-based approach to saying, hey, did you follow these rules, and do that in a very automated, intuitive fashion so that, it's not just, hey, you've got problems, but it's like, hey, we'll tell you, what the problem is, where it's occurring, how to fix it in many instances, or give guidance on that. And then support that across standards. So I think what's interesting is, one, if you look at the totality of code in an automobile, okay, and then you say, okay, now how much of that code is safety critical or security critical? And I know those lines are getting blurred a little bit. I mean, that's something we'll talk about in a minute. I think maybe kind of the blurring of those lines, but at the end of the day, it's probably 10 to 20% of the overall lines of code is what I've heard, some estimates, that are actually like really significantly traditionally ISO 26262, like ASIL CD type stuff, right? Well, this is safety critical, like important safety critical stuff, where static code analysis is not an option, it's required, right? There's certain things that are just required. And so as a result, as we scale, right, as we scale that development, the number of developers, the locations of the developers, it has to be something that just happens automatically as a part of that DevOps pipeline. And that's one of the things we're solving and helping, solve. So I think that's one thing. But I think there's some really good reasons, right, that everybody that's developing software as a part of this, as a part of, the development of an automobile and other devices as well, right? these standards, like you said, can be liberating and actually important. Like, so for instance, what about the supply chain? Like I'm an OEM, I'm buying components, and they're like a bit of a black box. There's however many lines of code in this thing that I'm buying, and I want to know that, hey, even though it may or may not be required by some country or some external organization that this is ISO 26262 compliant, we're seeing, I think, what OEMs maybe saying, hey, you AUTOSAR, MISRA, like, hey, you've got, there's some standard here with which we have to know you've kind of achieved that standard, and that just starts ballooning the number of lines of code that actually some of these practices are applicable for. So I don't know, talk a little bit your perspective on that.
Yeah, I do think that coding standards have a huge value in managing software coming through the supply chain, whether it's just a pure software deliverable or whether it's a highly software driven component like a camera system or a GPS or ADAS or whatever, right? What else are you going to do? I mean, that's really the big question for me. If someone gives me a piece of software and says, okay, go ahead and test it, it's like, oh, it's too late, right? Like you've already built the whole thing. If someone says, hey, here's the practices that we use, right? We're TÜV certified, we follow known best practices, and here's the reports that demonstrate that we don't just say we run coding standards, we can actually show you the outcome of the coding standards, and we know which standards have implemented which line in the 26262 standard, for example. We know how the requirement is matched to the particular, step, process, test functionality that we do. So I think, yeah, it's a super critical way to manage what's going on and to understand what the quality is coming in, and especially in a safety context, because again, if I'm downstream, I'm not unimportant, right? But I'm building a cool little widget. It might be the thing and the reason why people buy a car, but I'm deep downstream and I don't know the context of it. And as an example, if I look at automotive recalls in the last 6 months that are related to software, they're almost always camera related. And you don't think of a camera as a recallable item, right? As a safety, it's a camera, right? Like I have a rear view mirror. Do I need a camera? Well, the answer is if you have the system there, it's got to work, right? So it's partly we can control the supply chain, but partly the more rigorous we can stay inside the standard, the less likely we are to have problems as parts get repurposed or used in a context that we didn't understand, at the moment that we built the piece. Yep.
No, yeah, exactly. So I think I think all of that, right, is relevant. But let's turn to kind of the last little bit here before we go to Q&A, which is automation. So this all has to be highly automated, automatic. We can't put the burden on developers. We need to make it easy for developers. If we're gonna, like you said, it needs to be liberating. Part of liberation isn't just saying, hey, there's some rules by which you should govern, right, how you build this code, and some good reasons why, and it's going to keep you sort of on the rails versus going off the rails. But it needs to be highly automated as well. And I think this diagram is, I think this is what a lot of organizations that we're working with are either here or they're trying to get here, which there's a lot of elements here, right? There's this whole notion of containers, both in the cloud as well as local, and some standardization there. There's this notion of using, again, a Git-based pipeline for CI/CD or DevOps. There's this notion of integrating all of this with the IDE the developer's using. There's dashboards and reporting that we can gain a lot of really interesting information in near real time as well, because this is all sort of just happening. But talk a little bit about this from your perspective and some of the keys of how this sort of works and highlight again, maybe this would be this, also I'll just make one other comment, which is if you're interested in this and how this works and seeing this in action, right, we have a monthly demo that we do where we actually show this sort of thing working in real life and with real code and so forth. So go to parasoft.com and check that out. And also ask any questions you might have. But go ahead, Arthur. Let's close out with this, and then we'll get to Q&A.
Yeah, let me just hit some of the key points, right? Obviously, the devil's in the details when you go to set up a system like this. Whether you choose, a hybrid cloud, a public cloud, a completely private cloud, are based on the needs of your particular organization and how frequently you build and test and things like that. Really, have a lot of context. What is important is that you have something where you can produce a fully automated build with all the appropriate test artifacts, and that you do whatever it takes to get there, right? Like and by fully automated, I don't mean that at some point a button pops up on my screen and says, yes, no, next, right? Like you've got to get to that level where everything can get done so that you can move things along. Another key question here when you look at this, right? Like you see we have Git sitting in the middle, could be any, doesn't really matter, right? Change management system, source control system, but that you have something where everything sits and that it can feed both a fully automated build, test, and potentially deploy pipeline, as well as the developer desktop. And this is kind of the first two stumbling blocks, making sure that you're fully automated in your build process, whichever tool chain you choose, and making sure that you're not choosing process of when do I do it on the desktop? When do I do it in the build system? These practices need to be available in both. As a developer, I need to be able to run static analysis. I need to be able to run unit tests, right? I need to be able to run functional tests on my desktop to validate the code that I'm writing or that I'm fixing or changing. I also need the pipeline to be able to do that. So making sure that the tools that are there to support the process are available in the IDE where the developer chooses to work, not in some emailed report to them, right? But also that the pipeline can accommodate the tool in a lightweight deployable fashion based on how you set up, whether it's, old school cloud development with a big server somewhere, or whether it's a lightweight container-based, highly dynamic build system, that the tool needs to work with your infrastructure. After that, the next thing that kind of comes along in a safety context, in a regulated environment, and it could be safety, it could be security, it could be privacy, right? Like this applies to other industries as well, is preparing yourself for audit. Normally, like, audit's kind of an orthogonal task. Developers do their thing, testers do their thing, and then somebody runs around, like a mad hatter at some point, gathering data, trying to produce after the fact the reports that prove that they did the right thing. The system itself, the one that we set up, for example, it organically gathers data while you're running static analysis, while you're doing unit tests, while the build systems are going, so that you have these dashboards. First of all, they just help you understand, where am I at in the process? Am I close? Am I far? Am I meeting my deadlines? Am I going to meet my deadlines? But also at that moment of, okay, it's time to roll this up and get ready to deploy it. We need to have something we can hand off to the audit team. And it's all just there. There's no, hey, I've seen organizations literally spend 1 to 2 man weeks for half or more than half of their organization gathering information about what they just did for the last, 6 weeks. It all needs to be right there. And by that, I mean, you need full traceability. You need to be able to say, hey, this requirement in the standard and this requirement in our design lead down to this test, this practice, this unit test, this code coverage, this static analysis, this functional test. And it was executed on, July 14th, and it was successful, right? Like, you need to be able to chase results to tests, to code, to requirements, and be able to do that, instantly every time you need to do it. So that's really, really critical to the system. And in fact, again, I keep using the idea that standards are liberating, right? Like if you're following the standards, it's like having a senior developer kind of tap you on the shoulder and say, I wouldn't do it that way. Like, I'd do it this other way. And you do it. And so when compliance comes, you don't have a problem, and you don't spend a lot of your life gathering stupid data and reports, which nobody wants to do.
Yep. No, that's exactly right. Yeah, I do think again, I think this is very possible. We showed you, there are organizations out there using a very similar approach, and they're, it's transforming how quickly, how many turns they can make on the software, and again, creating a better existence for the myriad of developers they have, and where compliance and standards aren't a four-letter word, but are actually useful and valuable and again, highly automated, and integrated. So with that, let's go to some questions. Again, you still time, ask a question, go ahead and type it in. So we didn't talk, one very important thing we actually didn't talk about, I thought about putting a slide up and we didn't really talk about it a whole lot, which is the V model, right? I mean, anybody who's been in automotive development for any time period, or if you've ever looked at the ISO 26262 spec, right, you'll see clearly, obviously in that case, there's a double V, and so, the V model is near and dear to anybody in that realm's kind of heart, if you will. And so how, can the V model and Agile and this DevOps, CI/CD stuff, coexist? That's the first question. So
it's a bloody good question, right? And I do think a lot of people have that question, right? Again, to people who are used to a really rigorous process for their hardware and their software, look at modern development things and go, this is insane. And if you simply read the manifesto and don't think about what does it really mean for me, like what's the practical implication of it, you could easily come to a conclusion that Agile is not compatible with a functional safety, rigorous engineering based approach. But I might even have said the same thing myself 10 years ago, right? Like it was easy to think that it wouldn't work, but I see people doing it successfully every day. Big customers that are building planes, trains, and automobiles that again are using Agile because it's the only way to keep up with the competition, and have learned that, if we think about the basic implementation of Agile being iterative, like, yeah, as long as you have a safety regime, a regulatory regime that becomes part of a, let's say, continuous compliance, right? CICC, right? that you can do it, right? You can do it in smaller loops and it's not a problem. Maybe you're doing lots of little V's in a circle, right? But you can do it. And in fact, the rigor that the V model brings makes the CI/CD system more likely to succeed, right? So I expect as more and more organizations adopt Agile in a traditional V model world, they're going to be the ones that win.
Yep. So I think another question, and there's a couple different questions around this, so I'll just kind of summarize it, but what embedded tech stacks do you guys support or are supported? And that's probably, probably what we need is, people to come forward with their specific set of technical, their tech stack, if you will. What compiler are they using? What are they targeting, et cetera, et cetera. Like there's obviously a lot of different permutations, but we do support, we specifically, right, with our tool chain integrations, support many. And in fact, I think one of the cool things that's coming is we are actually re-architecting our tools. So instead of thinking of it as, hey, there's this piece of software, right, that you install and configure over here that's specific to, static code analysis, or how you do, has all these features built into this thing, and then you got to integrate that to a bunch of different stuff. Really, we're kind of decomposing that and saying, well, no, really we need these capabilities to be fully integrated into, right, again, a lot of the most common tools in that tool chain, so that the outcome is much more seamless. It's much more automated, and we can't comment a whole lot on that, but I would say, hey, if you come to, we're going to be doing what we call an embedded summit, so automated testing, quality, compliance, embedded summit, where we're going to have a bunch of customers speak, right? Industry leaders speak about what they're doing and how they're doing it, and some partners. I think we may have partners like IAR and tasking and some others, maybe even ARM. I don't know. We're trying to put some different panels together and so forth. But at the end of the day, you'll also be able to hear maybe companies like VW and others that are leading in many ways in some of these efforts speak. But bring those to bear, and you'll hear more about where we're going with that. But clearly, many of you have some specific tech stacks, and again, we work with a lot of companies. I don't know. You want to add any comment there before we go to the next question?
Just gonna say that yeah, there's so many different stacks, and we work with the basic ones, but also that it's kind of in our DNA. Like interoperability is easier if you build the tool to be interoperable.
Yeah.
And so, things like having command line interfaces, things like having small, lightweight pieces that are easy to deploy and can handle properly licensing and reporting in a container, like that's what matters, right?
Yep. Okay. I'm going to wait just a moment. There's any last questions somebody wants to type in here? We can fit in one more maybe. We're about at our 45 minutes. So let me look. See if there's another question that's relatively simple. There was a question about what tools does Parasoft provide. So I guess the easiest way, without talking about it, that there's one, clear tool that we sell into this space more than any other, which is C++ test. That's the name of it. It's pretty straightforward. But to see sort of how that works in conjunction with, again, like VS Code and a Git-based, pipeline and so forth. I highly recommend, seeing it in action. Come to or look at some of the replays, or come to our monthly demo where we kind of show that in action, and you'll see the tools there highlighted. So that's a good place for that. And I think with that, I think that's it for today. So I don't see any other significant questions. So with that, thank you so much, Arthur. Appreciate your time. Appreciate everyone who attended your time today. And again, this replay will be available. So if you didn't catch the whole thing, or you want to recommend it to a coworker, it should be available, and you should get a notification of that. And if you have other specific questions, feel free to reach out directly to Arthur or myself, and you can reach us in a variety of manners. I posted some of that earlier, but thank you again for your time. Again, our Parasoft's pretty simple, right? Parasoft.com is the domain. Arthur.Hicken, Matt.Klassen, or mklassen, or I don't know, maybe you just have an Arthur at Parasoft probably too. Maybe you even have do you have any special other ones like Code Curmudgeon at Parasoft.com?
Code Curmudgeon will get to me always, right? But yeah, Arthur.Hicken at Parasoft.com will work quite well. Or if you're, a Twitter type person, hit me on Twitter at Code Curmudgeon, right? That'll get you there as well.
Awesome. All right. Thank you, everybody. Thanks, Arthur. Have a great day.
Thank you. Bye-bye.